Hello, this is Damnesia and welcome to another video. I haven't made a video in a while. I don't really want to explain anything. It's fine. I'm just going to start out with this. I've been told I should start with tutorials on programming. So I thought, well, I could start with OpenGL and C++ and all that stuff, but that's not really a beginner level, and I want to kind of target beginner level for now and then kind of work my way up to the higher level. So I decided language I want to teach as a first language would be Java. And basically what I'm going to do is I'm going to give a little Java course, and it's going to be programming mostly. And then I'm also going to add a little bit of theory, just so people can kind of understand what's going on behind the scenes. And this will help with C++ tutorials later on when I start with them, which is why I thought it would be a good start to work on a language where you don't have to know the theory yet, but you can, and it's definitely going to help. And then after the theory is kind of settled in, I can start with C++ or some other language. So, well, I just want to explain what Java is for a lot of people that don't know. There's a difference between scripting and programming languages, and a lot of people kind of confuse the two and forget. Programming languages are more C-level languages, Java, C++, a lot of the other ones as well, while scripting languages are more the ones that are being interpreted by something, like HTML, which is being interpreted by usually something that was built in C++ or something of the sorts, or another C language. So those languages like HTML, JavaScript, CSS, those a lot of the other ones, Python, PHP, those are in a way scripting languages and not actually programming languages. So that's why I didn't start with those languages, because those aren't really programming languages but rather scripting. Then I want to get to what Java is. Java is actually basically a virtual machine running a cross-platform code that's rather interpreted by the virtual machine rather than by the actual hardware itself. That way you can build it and get it to run everywhere. Makes it a lot easier to build when you can just create it once and have it basically run wherever someone has a Java virtual machine. Which is the unfortunate part about C++, where not only can you not rely on the computer being able to run it, you also can't really rely on the size of certain variables, which is in itself also a problem, but we'll probably get to that when we get to C++. And yeah, so I've explained why Java, but the biggest reason is pretty much cross-platforming. That's pretty much the only reason. You can just build it once and run it everywhere that has a Java virtual machine. There's a lot of misconceptions about the performance of Java. Now, Java is not as fast as C++, even though there's quite a few sources that would show they're relatively on par once it's been compiled and once it's been running for a while, and the JIT has done its part in adapting it, because it actually checks for hotspots, in other words, areas of the code that are run the most, and then optimizes those parts the most. So once it's gone through the JIT, that performance difference isn't that big anymore, and sometimes it might even be the opposite way around, where Java is slightly on edge over C++. But generally I would say Java is not as fast as C++, but not by much of a difference, which is why I think it's justified to go as a first language. And even if you want to stay with this language, it is perfectly acceptable. It's not a slow language by any means. Slower doesn't mean slow. And yeah, so we've got a Java virtual machine, which is also a way for Java to make sure that the hardware itself doesn't get damaged if you make a mistake in the code, or at least it kind of avoids it as much as possible. Overflow, stuff like that. If you want to go into what those mean, you can go and research online. I don't really think I want to go into that. That's too much extra information, and most people just want to come here to learn programming. So I'll just stick to that. Anyway, the memory problems, there are some limitations with Java. For example, Java by default has a 1 GB, and a lot of people that run Java don't know how to improve this. So you're basically limited to 1 GB unless you create your own launcher for the Java program that automatically takes a bigger amount of RAM. But that's up to you to do, and you can't expect the user to remember to do this. Then we talk about slow startup, and in reality, yes, Java is a slow startup compared to C++, because unlike C++, it hasn't been compiled for that hardware. Rather, it's been compiled for the Java virtual machine. Java virtual machine has to interpret it kind of into the machine code, which is lower level, before it can start up. So that takes a little bit of time extra, with the whole Java virtual machine having to start up and everything. Generally, Java programs start slower, so that is definitely true, and a big reason for why Java is considered to be slow. Once again, unfortunately, people don't really understand the difference between being slower than and being slow, because everyone's just expecting everything to run as quickly as possible, and they don't care about the fact that some things may be able to run everywhere, and therefore have to have a little bit of a startup time just to get it to run on your hardware, because it's not compiled for specific hardware if it's going to run everywhere. So that's a little bit of a problem. Then we get the JIT. It's called a just-in-time compiler, and Java has this nice compiler where after a certain amount of time that the program's been running and iterating through something, it figures out where the hotspots are, in other words, where the parts are that the software has run the most, and I've already said this earlier, and then it tries to compile those ones to be the most efficient. It works on those and makes sure that those run really efficiently, and sometimes that code can even be slightly faster than C++, but not really something we should be looking into currently. And then in order to run Java, in order to program in Java, we're going to need, first of all, the Java itself, which I'm going to have to show. Alright, so at the time of recording this, Java 8 is the current one, Java 9 is around the corner but not quite out yet. So we're going to be using the Java 8 development kit, and you need the development kit to actually develop in Java and to run Eclipse. So you're going to have to download the development kit and make sure that it's all running perfectly on your computer. You just need to make sure you accept it, and then you go for the correct one and then install it. Not going to show how to install because I'm fairly certain most people would know how to do that already. And if not, there are tutorials online for that as well. Then next thing you're going to need is a Java IDE. IDE is an integrated development environment, and this is going to be what we're going to use in order to program in Java. So yeah, so we're going to need to take this one specifically. You can see there's for Java EE developers, but we're not going to take that. We're going to be using the normal one for Java developers. If you already have Eclipse because you've been programming C or C++, and you're just interested in Java in general, you can get a plugin for this IDE, which allows you to run for Java. But if you want two separate Eclipse IDEs, one for Java, one for C++, there's no problem with that. You can do that too. So I'm just going to go ahead and click that. I'm going to go into this page and try finding the latest release, because currently the Oxygen packages is the latest one, but it's not going to be the latest one forever. So if you're watching this later than the 20th of July 2017, you might want to look and make sure that Oxygen packages is the latest one, because if you just download this one and there's newer ones, it's kind of a waste. And I'm sure the new Java versions might not even support some of the older IDEs. I've seen that happen before, but I can't quote because I don't remember it quite well enough. Anyway, I prefer Eclipse, but there are a few other ones that you can get, mainly NetBeans, IntelliJ, and BlueJ, which is not suggested because it definitely doesn't help you. And you're going to have to remember the code off by heart, which is not really a good thing for industry. Anyways, in order to set up the IDE for Eclipse, you're going to need to download it, and once again, I'm not going to show how to install it. I'm hoping you guys know how to do that. So that's pretty much all I really wanted to go through with this video. I am going to start on Java programming as soon as I can. I'm hoping I'm going to have enough time, but I don't know for sure. So for now, this is it for this video, and see you next time.